and share my screen. So yeah, I don't know if you looked at the previous research reporting I did on mover heads.
I don't think so.
Cool. All right.
Or did I?
So in which case I will start from scratch. All right. So let's just actually get my files together. Okay. So observation. A thing models seem to often do is I don't want to be on a treadmill desk right now. A thing that models often do is in observed circuits is like look at a thing they seem to often do when observed in circuits is like what I call mover behavior, where they look at a prior occurrence of the next token and predict that comes next. For example, induction heads look at a thing earlier in the sequence that it thinks will come next and predicts that comes next. And let me just run this script from the top. And the interesting observation is that, the interesting observation with induction heads is that the current token appears in the past, and the important computation is done by the model's attention pattern in order to figure out where in the past the next token occurred. And this is kind of striking and interesting. And this also seems to occur with, say, the name movers in indirect object identification, where it's like, the indirect object is a name that appeared in the past. Look there, predict it comes next. And in the Python docstring circuit, there are heads that attend to the correct parameter in the function definition and copy it to the docstring. And there's a bunch of other circuits I've seen people look at that have similar shenanigans. And a separate motivation is that a beef I have with indirect object identification style work is that sorry, let me just change. No, this is right. A beef I have with indirect object identification style work is that it's very specific to a narrow distribution of like IOI style prompts. And what I want is what I want is to be able to say, okay, suppose there exists a general notion of heads. So my beef with IOI is that it's specific to this like fairly narrow distribution. And this means that the stuff in IOI is probably like polysemantic as fuck and doing all kinds of other things, plausibly represented in superposition. It's all very set. And to me, an interesting hypothesis that I want to test is like, it seems pretty plausible to me. There are things that are in general induction heads, in the sense that most of what they do is induction or similar things. And I want to see if there is a notion of like a general mover head where moving is like the main thing that it does. And how much sense is that making?
Yes, and then moving kind of different things, but in general moving, or moving something very specific.
So this is an open question. My prediction is that we are not going to see monosemantic IOI style name movers. I further have the prediction that yeah, I further have the prediction that this is messy. Yeah, and yeah, I think the prediction I want to test is, are there heads which seem to spend a good chunk of their time doing things that I will call moving, and which spend a good chunk of their time doing things that I would call like what's spend a good chunk of their time doing things that I would consider to be where is the signal working? Spend a good chunk of the time doing things that I would consider to be moving, and where like this is their main added value to what's going on. And yeah, so I spent last weekend poking around and trying to solve this. And this, and I'm just gonna like go through and summarize what I did. Also, because this will be helpful to me to remind me what the fuck I did, because it was a whole week ago. And you know, so many things happened in a week. It's outrageous. Yes. Also, please jump in with questions whenever. Questions make this more fun. Yeah, so I think I may have an existing move aheads thing. All right, so let's go with today. Okay, so recap of what I did last night. I yeah, set up these metrics where for each head, this is in Pythia 70M, so a 6-layer, 8-head per layer model. And what are the metrics, man? So I have head direct logit attribution. Just for each head, for every token, what's the amount it adds? For each token, I have the total attention paid to previous copies of the next token. I'll just move this to the side as I scroll through. So yeah, metrics, head direct logit attribution, mover attention paid to earlier copies of next token. I am not evaluating whether they are in fact, I'm not conditioning on there in fact being copies of the current token in the past. Then mover direct logit attribution. So the direct logit attribution of the head setting all non-mover attention to 0. If I just look at the value vectors on mover tokens, weight by the value, multiply by the logits, what do I get? And this is all pretty coherent. And then I have ratio, which is just like mover direct logit attribution, head direct logit attribution. And each of these is per token. And then I currently in my head data frame, I was adding like 90th percentile as the metric, because I found that when I plotted quantiles of the thing, 90th percentile seemed to be like the interesting one. This is a very stupid qualitative statement. Then I went down a big tangent because I realized that this was all slightly bullshit, because all of the heads, like most of the heads that seemed really important with like high mover DLA, also had high induction scores, where like this head seems like a big deal. It's very induction-y, where induction score just means give it repeated random tokens, look at the attention paid to the induction-y token. And yeah, so Yeah. So, all right. And yeah, so I'm like, fuck. This head was induction-y, this head was induction-y, this head was induction-y. Interestingly, this head was induction-y, but did not look induction-y. Another interesting observation is that layer 5 heads are just like really not very induction-y, which is kind of surprising. Sorry, layer 5 heads are not very mover-y, which is also kind of surprising. And because one of the reasons I looked at the Pythian models is I was like, they use parallel attention. This means that the final attention layer literally adds to the logits. So, if you're ever going to get a mover head, obviously the mover head is in the final layer. And nope, just does not happen. Which makes me suspect there's some like calibration nonsense happening, where like the model doesn't have that much control over the previous residual stream, other than like it has the token in it and it has some like cleanup circuitry that it needs to run afterwards or something like that. I don't really know. I find this a pretty surprising phenomenon. But yes. And anyway, so I have like a handful of heads that seem particularly mover-y and not very induction-y, where L3H3 and L4H2 seem like the most prominent ones, especially L3H3, because it's got like really high mover direct filter attribution, generally very high direct filter attribution, and it's not very induction-y. And yeah, probably scrolling through these notes might be more informative if I remember to copy graphs. And yeah, so what? Yeah, so I went down a big rabbit hole before I realized, oh shit, they're induction heads. And I now have a bunch of metrics that are like, let's filter out how induction-y they are, and now let's look at them. And okay, we can now look at the direct filter attribution of the heads, the mover direct filter attribution, if I filter out any token where induction is possible, i.e., we are predicting B from A and AB occurred in the past. Does that make sense? Great. And all right, so we are now like, okay, these two heads seem very mover-y, maybe these two, and then it kind of pretty rapidly drops off. And I then spent, yeah, so this is a quantile plot of like head direct filter attribution, where I was like, how the fuck do I actually visualize this data, man? It's terrible. And the thing I came up with was like, you do a separate line for each quantile for like a scan of interesting quantiles. And the main takeaway from this is that if you look at like this one or this one, they are like kind of coherent and interesting. And yes, I should have ones filtered for induction at some point. Yeah, scatterplot. I cannot even remember if I filtered these for induction or not. Whatever. And this is not super interesting. And then I went and did a bunch of investigation of like specifically heads like L3, L3H3. What are the things when it's like particularly important? Kind of sampling from things where it seems to be doing an interesting mover-y thing, but not literally maximizing. And found things like this, where blue is, I believe, attention. This is the current token. This is the next token to be predicted. And it's doing this kind of like opposite induction, which is cute. And did some playing around. This was, yes, this was some like weirder, fancier induction where it knew from the that it should look at the back here. Actually, no, I think about it. This is not induction. This is like significantly fancier than induction. It's like detecting the subject of the previous sentence. It's like, in some sense, a kind of variant of indirect object identification. I don't know, man. Yes. And so, man, I don't even remember what's up with some of these. Oh yeah, a very cute one was if it has this thing where it's like blah blah blah, I have and, how do I predict that export comes next? And import, export, and customs occurred in the past. And it's like, well, let's put 50-50 on export and customs. And if you look at the attention, it like basically does that. And it's very cute. And then a bunch of shit that I just like don't really get. And I don't really know what to take away from this. I think the observations I have are like, okay, this is interesting. This is like cleaner than I expected it to be. Sorry, not clean. It's sparser than I'd expected it to be, in that there is just like this one head that seems really important, and a bunch of other heads that seem much less important. It's also kind of a mess in that it's doing a lot of different shit in different contexts. But they do seem to be specializing this like big head for doing that. And then when you look in qualitatively, it's like, oh my God, this is such a mess and so many different things. And to me, the like three interesting next steps are, yeah, so what are the interesting next steps? Also, how much sense does that massive brain dump make?
What did you say?
How much sense did the massive brain dump make?
The massive brain it does.
Beautiful. What
Yeah.
feels interesting to you about exploring mover heads?
Yes.
What feels like an interest? What feel like interesting research directions?
I don't know.
Ah,
At the moment, I'm just trying to follow.
fair
But
enough.
yeah, I was also wondering the whole time when I read these other papers that like had these, for example, these probes or whatever that only look at the token that is basically at the position right now. But in the
Yeah.
end, the network or the model wants to predict the next token. And it's like, okay, where in the model is the, yeah, like where in the model is the model processing the current token and when is it predicting?
Mm.
I think like this kind of weird moving stuff that you just explained, that's quite interesting.
Yeah, I mean, if you're in the market for research project pitches, I think doing sparse probing on retokenization neurons seems super interesting to me. Like, can you tell whether there are, sorry, can you tell whether there are neurons where if the model thinks a certain engram is coming, it like outputs each thing in it? And I think this is probably possible. I think this would be extremely cute. And I think this seems like an actual meaningful statement about the model's beliefs about the next token in like a specific concrete setting. And I think that's a very cool project you want someone to take on that no one has yet claimed. Anyway, end sales pitch. So, all right. So to me, the like, yeah, so key thing from last time, lol, I need to filter out induction. Induction massively dominates. And yeah, L3, H3 seems very important. What else? Which was the other one that seemed like a big deal? And L4H2, somewhat important. And okay, so 3 clear directions to go in. Direction 1 is just speeding up my qualitative analysis for each, where I don't know, I was just manually picking out like tokens and dataset examples and poking around, and it seems like I can do better than this. And yeah, the specific thing I'd want to do is just like build speed up qualitative analysis, build a data frame with the key metrics for each data point, which is like print the token, like print the end token and the start token plus context of 5 tokens around them. Print, yeah, that. What else do I think is interesting? Attention paid from current token, attention paid to prev occurrence of token, both argmax across all previous occurrences and sum, and the mover direct ledger attribution and the mover DLA from purely the embedding and MLP0. And yeah, those seem like pretty legit things that are worth looking at, I think. And then, I don't know, make a data frame, sample things from this, explore. Seems like a pretty legit thing to do. I notice I have a pathological desire to optimize everything and make it beautiful and vectorize, and I should ignore this and just do something stupid in a for loop because there just aren't that many heads, goddammit. I'm also currently measuring all of my metrics by just giving the model like how many prompts am I giving it? I'm giving it like 300 prompts over 256. And this is kind of pathetic, and I should be more ambitious. Though it turned out to be surprisingly legit. Anyway, so the next direction I want to go in is looking at other models, especially GPT-2 small, but ideally just making code that can scan over many models, since it just really should not be that hard. And it'd be kind of nice to get like a saved data frame of how mover-y each head is in the various things. What else seems interesting? And then the thornier question of so there's like the question of what it would even mean to like conclusively show that a thing is a mover head or is like mostly a mover head. And I guess the thornier question of what it even means to show that something is a mover head. And the things coming to mind here are what does it even mean? The things coming to mind are most of its impact on loss comes from the direct logic attribution. If we resample, yeah, this implies if we resample ablate the head, then but match in its logic contribution correctly, model performance should not significantly decrease. And most of its direct logic attribution contribution comes from mover e-ness. And I don't actually expect either of these to be true. And in fact, I expect to run into some like shenanigans where it is like not actually all that true. And this is sad. But it would be pretty interesting to see if we can like quantify the degree to which it seems somewhat true, etc. And that seems pretty cool. Okay, so those are a bunch of observations. What next? So yeah, I think I want to do this approximately in order because that will involve procrastinating on the hard bits and because I'm so interested in these. Any thoughts or questions on this analysis?
No, I think sounds good.
Great. All right. So yeah, my code is a fucking mess, so I'm going to make a new file for, I don't know, qualitative token analysis.py. And yeah, basically just like go through and just copy over the relevant bits. So I don't know. This is a stupid thing. There is a magic line of code that I need to put in because otherwise it will hate me. Oh, transformers cache. Bullshit. And yes, if I put that in, it will cache Hugging Face models in here rather than somewhere else. I wanted to cache it somewhere else because that'd be annoying. And yeah, this seems great. All right, and let's move. Yeah, so this is model and dataset creation. And these are utils, which I think I've mostly moved to a utils file in like a shared library. So I don't just have to copy around a fuck ton of utils between projects, which is good. And yeah. Yes. Yeah. Wait, what does this not? All right. And so great. These are some various cute utils, which aren't really that interesting to get into. And yeah. So these are all metrics that just take each data point and store it. And probably a thing which is worthwhile to do is to store everything on the CPU, because I'm deathly afraid of getting ooms, and basically everything I want to do should be pretty easy on the CPU. Anyway, and yes. Yeah, so the above are the load and run the model parts. I'm gonna make this 1024 because it's just pathetically short. Oh yeah, I should set a random seed. Setting a random seed is always like a really good idea, because if you do not set a random seed, then none of your results will replicate when you rerun the model, and that is a sad thing. Oh, lol, I already give it a seed to shuffle along. How thoughtful. So clearly past me knew his shit. Right. And so this is a nice function. And yeah, so this is a function for get the induction score of heads, and sorry, there are ways in which it's just less interesting to be watching take over from an existing project, but whatever, I like this project. All right. Did this all just magically work? Oh my god, it magically worked. Oh. Cool. All right. That sure looks like a heat map of how induction-y heads are. And I should also probably just add this to my useless file. It seems like a generically useful function. And thanks to the glory of auto reload, this should just kind of work, except when it doesn't. All right. Life works. It works. All is good. So yeah, so here I have some copying score stuff. I think this seems broadly pretty easy and reasonable to just copy. The stuff this code is doing is just so basically this code is just testing how copying like the heads OV circuit is, and using the janky ass eigenvalues score of like how much are they clustered around the positive real axis, which I don't know if you came across that in a mathematical framework. I'm not convinced it's a particularly legitimate metric, but it sure seems to track something. And yes, oh, let's also create a show data frame function. I should possibly remove the beautiful print things function. All right. And now I want to copy over the stuff. At this point, am I just copying over the entire thing? Whatever. Okay, so now I want to copy over the things that are about filtering the data set. And yeah, this all just seems pretty legit and doable. Be right back. All right, so this is all basically code. Oh man, why is this sad? Oh, it's because the did I put induction mask on the CPU? Oh, well, all right. I should probably just set a device at the top so that when I use this variable everywhere, so I can use this variable everywhere rather than doing something fuckier. Great. All right. And cool. All right. So this is, yep, this is the same data frame I had before. Life is good. All right. And so what next? So now I want to, yeah, I guess probably just save copy of this file as, I don't know, just produce token metric data frame. And I guess I can just, yes, dataset name. let's just like run this shit on GPT-2 small and see what happens. Ooh, it's using safe tenses now. It's so exciting. I can be marginally less concerned that something will break into my computer and break the cloud box that the cloud provider I'm using owns, which I guess I don't care about that much. Sure is questionable, but Pickle lets you do arbitrary remote code execution. Anyway.
Nice.
Yes. All right. So words, things, understanding. Yeah. So, okay. So I'm just going to leave that running in the background and see what happens. I'm surprised that 16 gigs of GPU memory is consumed. But I have 80 gigs, so who gives a fuck?
And that's a 70 million parameter model?
GPT-2 is 160 million.
Oh, that is GPT-2. Okay.
Sorry. This one I rewrote to use GPT-2.
Okay. I thought we are still on the Pythia model.
This file I'm indeed on the Pythia model.
Okay.
Very consistent. I just have two separate files open because I roll.
I see.
But yes. Probably my coding structure is kind of dumb, and I should instead just have this be a generic file that can be imported. But also that sounds like effort. Ooh, there is a head whose DLA ratio is NaN. That's so cute. I'm surprised this happens for exactly one head. That's kind of fascinating. I also guess I should probably... Sorry? Sorry, what was that?
Oh, I didn't say anything.
Oh, all right. Okay. This is all an interesting mess. I am pleasantly surprised at how fast this gave me data for GPT-2 small. That's probably a sign that I was insufficiently ambitious. And I also am just observing that having two files with the same code is going to be horrifying. And so what I should instead do is refactor all of this into like multiple different functions that can be imported or just run. And this will save me a great deal of pain. Okay, and yeah, I am just going to do that. Except I don't really like standard Python conventions, so I am not going to do this in Python style. And we will see how much of a mess that makes things. So, all right, let's call this get head metrics. Yeah, head metrics by token. Then there's get head metrics aggregate, which this one should return the tensors of the head matrices and the dataset filtering musts. Nah, fuck it, I just really can't bother to make this code nice. I will instead just have this file import everything, because this is clearly a reasonable and principled solution to the world's problems. All right, what happens if I run this? Cool, all right, seems happy. Okay, so a thing which is exciting about doing this on GPT-2 Small is I can look at how much the various heads in IOI are implicated as mover E things. And I do indeed see L9H9 and L9H6, which I believe are the two primary name movers, score highly, which is exciting, but also not that high, which is unexciting. And I guess everything's fairly low, apart from this head. What the fuck? Yep, that sure is. Huh. Wild. I guess a layer 0 head. I have on average 0.2 direct logic attribution. That's so much direct logic attribution. What the fuck is going on? And okay, so if I look at, all right, so here it's sorting by the mover direct logic attribution for no induction. And for these heads, it looks like what on earth is the code I used to define ratio DLA no induction? Oh, I used the quantile of the ratio. That seems probably incorrect, I think. Does that seem incorrect? So if I take this head 10.8, Plotly will possibly get sad. I'm telling it what a histogram of 200,000 things. Lol. Let's zoom in a teensy bit. Okay. Let's clip that at 20. And let's try that again. All right. This is looking slightly less insane. Though I guess I basically only care about it being between like, I basically only care about it being between like 1 and -1. Let's clamp it to these and then hopefully get a like sane looking histogram. Gah. All right. So hmm. All right, I have no fucking clue how to interpret this. I'm just going to go with the ratio DLA metric not being very meaningful. Oh, yes. And at the end of this, I should have a DF. Let's make a head scores directory. All right, this is beautiful. And so, wait a minute. I can just download this and open this in a spreadsheet. Seems great. I guess I'm also, I kind of also will just want to go run this on like a bunch of other models. Like, let's run this on GP2 Medium. And that sounds fun. And after that, let's run it for GPT-2 large, because that also sounds fun. And I'm sure nothing will go wrong with me using my code like this. And GPT-2 XL, which I'm sure will not cause any memory ooms whatsoever. Will be great. All right, so let's just leave that to function. And see what happens. So, all right. So I have this CSV and I want to download it and just go and actually look at it. And oh, lol. Do I even have a spreadsheet looker installed? Quite possibly the answer is no. Ah, all right. New plan. I will use Google Sheets. But god damn it. Incredible. Though I do lose the color coding. I kind of like the color coding. Is there an easy way that I can add a column-wise conditional formatting on Google Sheets? Hmm. Not ideal. I will just give color scales to the things that I care about. Even if these are stupid ass color scales. Um, nope, not what I wanted. Oh, do I add? That's great. All right. Now I want to sort by this. And I want to freeze the label. Amazing. This is almost actually worth the effort of fucking around with this. Maybe. All right. All right. So this is mover direct logic execution and basically corresponds to a bunch of heads. All right. And if I look at the IOI circuit, that probably is not. Actually, what happens if I Google IOI circuit? I did not expect that to work. If you Google IOI circuit, do you also find this paper?
Yes.
Wild. I'm very impressed this comes above things like International Olympiad of Informatics problems about circuits and shit like that.
Yeah, yeah.
Oh. Wait, do they have more citations than my grokking work? It's outrageous. All right. What are the things they claim to matter? So um let's see. So here is their beautiful diagram. They are like 11, 10. Yeah, so let's also color this. And this. All right, so what's going on? The negative name movers have unusually low direct logic attribution. Yeah, green means fairly low. The induction score is surprisingly high. Wait a minute, what? Oh, I only applied this from the first however many. That explains why it looks stupid. All right, they're like weekly induction heads. And 11, H10. does basically just work. And then if we filter out, yeah, and they have fairly high mover retention, but basically no, what? They have basically no mover direct logic attribution. Huh. Oh, so if they systematically have negative mover attribution, then that will show up as 0 here because I'm taking the 90th quantile. And so a very interesting thing to go poke around at is like, what's up with that? Then there's, yeah. Okay. It also occurs to me I should probably just check how big even are the data frames that I'm making. Cool. All right. I should go and edit my code to just save all of the big masks and shit that I'm making. So they're also trivial to regenerate. And yeah, so negative heads are like sharply at the bottom, which is pretty interesting. Well, I guess they are only at the bottom in the sense that like they are 0. Which in and of itself is kind of surprising. Like, how are their heads that are like here? What the fuck? How is this possible? I'm so confused. Like, this makes no sense. Do you have any hypotheses for how on earth it is this?
I don't know. I have no clue.
All right, so it looks like for the things that are 0, they are sorted in layer order. But it's still kind of striking. There's also maybe suggests I should be putting means on here. So I'm pretty confused about how I would interpret mean. Then in terms of the name mover heads, we have well, you have this head that's like 14th, and it's like, yeah, really not incredibly mover-y. It's like a bit mover-y. Ditto L9H6. And L10H0 is, wow, like 44. It's got high direct logic attribution, pretty low mover score, and basically nothing in terms of mover direct logic attribution, which is fascinating. I should be taking notes on this. So, observations, GBD too small. Observation 1, it's, yeah, observation 1, negative name movers have 95th percentile of the, yeah. So if you filter out induction, mover atoms on the higher side, they have a bit of head direct logic attribution, but not a ton. Okay, really, what I should go do is see if my code oomed. All right, where did my code break? No. Sad. Sad. I guess the obvious fix is this. And I'm kind of curious what happens if I make that fix. But anyway, all right, I'm going down a bunch of tangents. Returning to what on earth is going on here. Yeah. My mover heads are somewhat mover-y, but not amazingly. Rank. Back up. Maybe heads. Man, where are the backup heads? L9 H0. Nah. Basically nothing. Though it does have unusually high direct logic attribution. Oh wait, no. The layer 9 backup heads are fake backup heads. So I don't care about them. Because they are in the same layer as the name units. They cannot be backups in any meaningful sense. But this is an artifact of the first draft, first approaches to the paper where they'd not noticed the true nature of backup. All right, L10, H1, I'm going to tentatively call boring. Ooh. So L10H2 is ranked above the name movers, which is fascinating. And has like high-ish mover attention and high-ish mover direct logic attribution, and generally fairly high direct logic attribution in general. Though the mover DLA is like a pathetically tiny fraction. So who knows? Um, um, all right, so we'll have H6. Not that much. Yep, I'm just gonna go with nah. Interestingly, these are all looking like surprisingly induction-y. L10 H6, boring. L10 H10 also seems kind of boring. Just not much. Ooh, L11H2 seems reasonably high, but a tiny fraction of its DLA comes from moving. And yeah, I'm gonna go with not super Interesting. And yeah, it's kind of not obvious to me how much I should even care about mover scores when they get below like 0.01, because that's just kind of dull. And yeah, I am also using the 95th percentile, which is kind of an arbitrary threshold, and like plausibly different models need a different threshold, and like I don't even know, man. All right, so did this crash? Wild. That that was not the place I expected this to crash. Wow. It crashed when computing the induction scores. Hmm. I don't even remember what this graph is. Probably this is a graph of something sensible like the induction scores. But anyway, this is a very pretty pattern. This is a data frame of all of the heads in GPT-2 large. And well, it took 36 seconds to go through the list. I should possibly not be caching these. But it is plausibly not that interesting to cache these. All right. Wait. Okay, so I think what I want to do is go and write some code that will qualitatively analyze what's going on with these using the big data frames of the per token stuff. And yeah, also, I don't know, questions, thoughts so far?
I think I'm good so far.
Nice. All right. Questions, highly encouraged. Also, telling me I'm wrong about things, highly encouraged.
I'll try, though. Although I think today I'm mainly trying to understand things.
This seems reasonable. Maybe you're failing to understand things so I'm wrong, though. Who knows?
Maybe.
And yes. All right. So I now have working code, and there are probably things I should do with that working code. So, okay. So a couple of questions I had just like poking around. What is the histogram of the head direct logic attribution for head 10, 7?
Then 7 was the backup move ahead, right?
Negative.
Oh, the negative. Okay.
And yep, sure does seem like there's a negative skew. And the other one is 11H10. This is using my all-time favorite keyboard shortcut of Command D, which just lets you jump to an instance of the next thing. Wonderful. Oh. Interesting. So all right, so I observe that there are enormous spikes. It's never fun. Probably the enormous spikes are there because of and so I have this matrix of like which tokens are movable, which if I've done my job right, is all tokens where the next token also occurs in the past. And so I should be able to take kill. All right. So on tokens that are movable, it is still mostly 0. And it is almost never positive. That's exciting. Yeah, fascinating. And I guess one way this could all be shaking out is if it's like relevant to, I don't even know what I think this would be. I don't know how to interpret this graph. Um, okay, so what am I interested in here? So yes, I should also just flag, I'm kind of tired, so I'm not shading this research. It's like optimize for the most important thing. I'm shading this poke around and have fun. So I think I wanted to go do a bunch of qualitative analysis on what's up with these heads. I think it would be cute if I could do this kind of properly and like actually get something that's at least like easy to efficiently do. And when I look at my mover analysis file, one of the things I have. Hmm. So this sure looks like a bunch of code that is somewhat relevant to what I want to do. So okay, what exactly is interesting? So the hmm, what happens if I try to run this? Hmm. Okay, not really what I'm looking for. So let's just copy over the key functions. So what exactly should the architecture here look like? So let's plan this out. Um, okay, and what exactly do I want to do? So Okay. So I basically feel like the thing that I want is just summary statistics and the 5 tokens around either thing. And then if I had that, I'd basically be pretty happy and like be able to understand it. All right. So um, yeah. Anyway, all right. So yeah, it kind of feels like if I literally just had this, it would feel basically fine. And so hmm. Yep, I'm just gonna write a function that does this. Okay, so all right, so
What was PLP?
I'm using PLP to mean the log prob of the correct next token.
Ah, okay, got it.
Attention is P stands for predicted log prob, which is plausibly just a terrible name. I should rename it to like CLP for correct log prob or something.
Okay.
Um, yeah. So all right. So those are important things. And yeah, honestly, I feel like if I had yeah, I guess it feels like the main things that are missing here are just like, what is the relevant source token? And I do have that data. Um, whatever. And and trying to get the attention pattern. Man, but it's doing fine. Why does it tell me this window is no longer responding? What? I'm so confused. Let's reload the window. Okay, so I am just going to edit this function to do all right. I am just going to rerun this, but getting a I'm just writing boring code. What? Oh, okay. So what I want to do is take a head and see how many data frame, how many tokens do I have? I think I have like, well, I have like 250,000 tokens. Should be easy. So what I want to do is focus on a specific head. Let's say, yeah, layer 9, head 9. And then make a big token data frame. Yeah, there's a -1 in here because I'm removing the last token from everything. And okay, so cool. All right. Oh, which ones are the arrays of the wrong length? Lol. Oh, these things are token specific, not head specific. This makes sense. Oh man. Why is predicted token such a sad list? Oh. Oh. Predicted token has the wrong shape because predicted token is all right, whatever. Okay, so what exactly do I want to be doing? So the really obvious thing that I should be doing is just having a so I want to this code was just bad. So many bugs. That sure is taking a really long time to reshape. Well, I'm sure it'll be fine. And nothing will blow up my GPU. Wait, I think this is on the CPU. How is that taking more than 30 seconds? What is going on? Cool. All right, it's done. Um, all right, it's indeed returning things of the correct prompt. Seems fine. All right. So I'm now just like doing a bunch of janky ass code to try to make this all work. But where's the sad? All right, I might finally be able to make a working data frame to be an absolutely historic note. God fucking damn it. Let me just deal with that. Bah. All right. So I would like to do something exciting, whatever that even means. All right, so now what I would like to do is say, yep, I'm just doing boring munching right now. All right. So Great. So I now have the predicted token thing, which is the token index of the thing looked at. And it would be kind of useful if I could yeah, I can do like is moving as predicted token for current token. And I can also so what I really want is to look at the previous token, at the token looked at in the past and the like 5 tokens around it. And this basically should be pretty easy to do given the predicted tokens list. So, okay, argmax attention index to context. Yeah, for this one, I probably want to yeah, so how big is argmax of the boss? Oh man. And all right. YOLO. So yeah, this is just a big ass list of strings that is the token most attended to that is not the beginning of sequence token. And
Why are so many strings doubling?
so this is for each destination token. What is the source token that it looked at the most, plus the 4 earlier tokens. And so this is just saying a bunch of this specific head often looks at the same token from a bunch of destinations. Which is like not incredibly surprising. Okay, so I now want to take so all right. So this is a big ass list of lists. And I want to flatten it. And cool. Oh yeah, I should make this. I just observed that is moving was true for the first token because it's just attending to itself. But like that's not what I care about. Boy, this isn't what I want. I would like predicted token to be equal to the value of the next token. All right, so great. And the context source tokens look dumb. Fine by me. Okay, so okay, so what do I want to do now? The obvious thing to do is just token df, sort values, mover DLA. And be like, YOLO, let's look at the first 100. Okay, so interesting. There's a bunch of these where it has really high mover DLA that completely failed to predict the next token. Just kind of fascinating. Um, uh, Wait. This is broken. I expected this to be showing me it attending to Sue, but it's actually showing me this attending to Mary. And I guess this is because argmax without boss is just offset by 1. If I take pile tokens, 399, 240. Oh, wait, so 23. Oh, it's because my code just offsets by 1 because it never reaches 0. Sure, that's a boring reason. All right, so what's going on? There's a bunch of basically induction-y tokens. Yep. It's like, I'm a little bit confused why this says H. Yeah. All right, whatever. You get weird stuff when you extremize. Yep, all right. Lots and lots of induction. Let's take the obvious solution of all right. And so now I can also get this cute plot of the direct logic attribution. All right, I've totally forgotten what head like. Cool. I'm looking at head 9 in layer 9. And I would like to be able to understand what is up with it. And yeah. Why does this keep happening? Why does my code hate me? I am gonna probably go to bed in the next 5 minutes. I should probably just get rid of these histograms. This is probably part of my window. It's very sad. All right, so these are cases of high mover direct ladder attribution. And what? Hmm. All right, so what's going on here? It claims that this one is not induction, even though that just totally looks like induction. I think part of the problem here is that these are not actually clearly tokenized, and probably what I should go and do is all right. I am going to just do a for loop. What? I'm so confused. Ah. Great. All right. Let's just let that run for as long as it needs. Well, unless possibly my code sucks and it's just going to take forever. Which is entirely plausible. All right, this is kind of taking forever. So let's do this quantitatively. But why did that run instantly? Ooh. Well, it will take a minute. I can afford to wait a minute. So I will take advantage of the minute to rewrite this to be faster. Where I think the performance bottleneck is going to be the tokenizer. And in particular, this function under the hood, I jump the definition, is running this function, which for each individual token converts it to a string, which is just laughably inefficient. And what I should instead do is do model.toStr tokens run process as a string processor on all of them, and then life will be good. But also I can't. All right, it's gonna be great. All right, so now what's happening? Oh, okay, so this is doing induction from token to token with space. This is some fuckery where APAP is repeated. Hmm. I think I also want context dest. I'm just going to make some dumb print functions. So I'll want through things here in case there are performance bottlenecks. All right. Now let's study this. Wow. Oh. Ooh. This is much more like it. All right. So what's going on here? Oh, the fuck this is. These are new line induction, including in a way that's like actually robust to tokenization fuckery. So like split token induction. Is this large enough for you to read? Yeah, this is fancier induction. Weird. This is some kind of like probably misfired funky induction. I don't really know. Yeah. Yeah, it seems like a lot of what this is doing is like complicated stuff. I do not understand what the hell is up with this one though. What? What? Whatever. Um, hmm. This is doing induction between like full stops and commas. Huh. So this is more like creatively identifying the subject. This is more fancy induction. Hmm. Fascinating. Yeah, so there's quite a lot of like figuring out the surname of the subject, which is kind of IOI like. Yeah. Ooh. Now this could be IOI like. 3312170. 170.
So the tokens you are just selected are from the sequence that you just looked at on the right?
Yes.
Okay.
These are specifically from which one? This one, because that's got a name and Alicia, and then it's like said Alicia, and I'm like, oh, that looks kind of IOI like. Fascinating.
Okay. Okay. And now you want to investigate whether it's really IOI.
Yep, pretty much.
Okay, cool.
Ooh, that's exciting. That sure looks like weirdly sharp IOI. Jesus Christ. Whew. Huh. Well, that's really cool. I'm sure gonna save that. All right. Which, ooh, this looks IOI like. 686-213. Ooh. another bit of Iowa in the wild. Would also be pretty cool to look at direct logic attribution. Hmm. That sure does not look like what I was expecting to see. Oh, that's much more like it. Gotta love off by one errors that happen half the time they ever try using direct logic attribution on anything. Ooh, and this is fairly IOI-like. Huh. This is like typo correction? Fascinating. This is like induction around fucked up quote marks that get tokenized as two mystery characters because fucking byte pair encodings. Huh.
But is it typo correction or is it just don't caring about the typo?
It's a good question. So I mean, we can just feed it in. I mean, I would call this typo correction. Though, obviously, when you're extremizing, it's kind of easy to be bullshit. Um, and it does just kind of bug. Oh, one thing which would be very interesting to look at is a scatter plot of Well, sad. The observation was, well, these both seem to be name movers. They both seem to be activating here, and they both activate in the IOI task. Do they, in general, co-occur? To which my answer is like, I don't know, man. A little bit, maybe. Oh, wait. This hates me. Please forget about that. Hmm. This looks probably positively correlated. Yep. Those sure are not. These sure do not align with each other. I replaced head 6 with head 5 in that layer. And it's like, lol. Nope. This one is particularly cute. It's just like such an insane quadrant. Ooh, these are pretty solidly negatively correlated. That is cool. I think this is like some amount. Some amount of evidence for the hypothesis that these are like consistent backup head pairs. Interesting. And the move ahead, anyway, tangents. But yeah, I'm comfortable calling that typo correction. Hmm. Yeah. Oh, I guess another observation is just that it is very specialized for like name relevant tokens. Like so many of these are names or tokens in the middle of names, which is pretty striking. All right, I'm not going to get much more from looking at this, but that was good infra setup. I am happy with that. All right, so if I do all right, L9H11. Oh wait, this is the thing. It takes a minute that I can be bothered to optimize. I still can't be bothered to optimize it. All right, so I guess one of the big problems of what I'm currently doing is just that it's sorry. One of the big problems of what I'm currently doing is just that it's like so all right, final investigation of the night. What? Oh, keep being caught up by forgetting I'd already defined the data frame. What? What? Um, ah, those sure seem like incorrect figures. I sure hope that I did not fuck that up in the previous investigation. And I sure hope that I was not spending the entire time looking at the context for head 10.7, because that would be weird. Though it's also plausible that they have very similar retention patterns. And I'm quite curious. Anyway. Let's load, do a bunch of staring at the top examples. I'm going to head to bed. Nice. All right. What? What? I am very confused. Huh. Okay, so it looks like there's something insane about what the token next is. So this is the final token in there. What the hell is that? All right. These are insane characters that do not exist. Let's ignore this and move on. Soft hyphens that are not read correctly under a UTF encoding. Man, this is the kind of bullshit you get when you start actually when you have the temerity to try to interpret models. It's not worth it. Just give up. All right, so ignore this bullshit. So it's really good at hyphen style. It's like, what kind of dashes get used in this text? Let's move that to the end. And this is like an entertainingly large fraction of what it does. At least on the top end. What the fuck is that? Oh, okay, this is space colon.
What's that?
This is space followed by a colon.
Oh.
So it looks like quite a lot of what it's doing is some amount of like detecting the separating characters used in the text. All right, all right, all right. Is there anything that is not? Wait. It'd be fascinating if like the thing this head is doing is being like, man, punctuation, so important. It changes so much. I should figure out the relevant punctuation character, current thing, look for it in the past, and assume it will come next. This is nice. Oh my god, it's a word. All right, I'm interested. 585129. Huh. So we've got the same text repeated. So it should be doing a lot of induction, which means it should have been predicting Chris. But instead, this head is like photo. Photo is the important thing. It must make photo happen. And this is kind of fascinating. Fascinating. It sure would be nice to have any clue what fuck us up with these MLP layers. Just look at it and I'm like, I don't know what you're doing, man. Very confusing. But all right. Wait, no, okay. Fascinating. So there are some induction heads that are boosting Chris. They're looking on a ton. There are some LP layers that decide to reinforce it. And then just like this fucking thing. I guess that's an abstract argument in which you could say that photo colon is like the punctuation character here. This is probably too nonsense a claim to actually roll with. But it's kind of a cute idea. It's just so much punctuation, man. The guy. It's probably doing something a bit more complex, maybe. Man, literally copying punctuation. It's kind of fascinating. Sometimes there's some different kinds of punctuation. What? All right, it's fucking wild. Out of 200,000 data points, the top 500 it's moving weird ass punctuation characters around. That I'm increasingly sympathetic to calling this a punctuation move ahead. So all right, this is an instance where it's not literally just moving. What's up with that? Oh, fascinating. And I hate models so much. All right. Final thing is all right. Insane punctuation characters it is. All right. So is there a sensible thing to do here? Oh, I want to figure out like why is it moving the V around? So the model seems pretty fucking good at telling that V is the next thing. Okay, so these are contexts where it's most strongly appending to V. Hmm. Anyway, I'm gonna call it a day then. I hope that was at least vaguely educational. I appreciate the company.